So yeah, thanks so much for having me, and thanks so much for the invitation. I really appreciate it, and I'm really looking forward to hearing what you think about our work today at AUAR. So yeah, my name is Mollie Claypool, and this talk is called Automating Architecture in Large Numbers. And at our mission is to accelerate the mass adoption of automation by providing the technological infrastructure for a regenerative, fair, and inspiring built environment. Our team is comprised of myself and Jill Retson as co-founders of AUAR and of AUAR Labs, and we are supported by Ivo Sembler, who is the ex-CEO, or Ivo Tedbury, who's the ex-CEO of Sembler, a modular robotics startup, and Kevin Sai, who is our timber innovation modular systems expert, and he works across our technology stack of AUAR. And beyond us four, there are 6 other individuals that work with us, of architects, engineers, developers, activists, and builders. And sorry. So I'm just going back. So in our labs at UCL, we have explored for many years the intersection between design and manufacturing. And we've done that both through speculative work around the way in which we can more closely bring together design techniques and simulations to design fabrication and robotics. We also have done this by testing. So for example, in our work in the lab, we have directly mirrored all of our simulation-based work and work with AI and use that as a way to analyze and understand how this can transcend into the building space. We looked at this in more depth in our book, Robotic Building, which was published in 2019, and has sort of laid the groundworks, I would say, for our work in AUAR since then, really trying to understand how we can best use automated tools and technologies to further a mission that's really focused around more just built environments. So in that book, we looked a lot at questions of labor, at questions of the implication of platform-based thinking, and also did a retrospective analysis of 5 different categories that we saw emerging from around 2010 onwards in terms of how technologies were being used in digital fabrication. And those categories were print, craft, many, assemble, and diffuse. And we're really focusing in our work on the assemble and diffuse strategy now, I would say. So if you have more questions about that book, feel free to get in touch, or you can buy it. It's still for sale, which is really cool, at your local architecture bookshop. So the baseline of our work is that housing needs to change. We know that we need to build many homes over the next 80 years, particularly in developing countries. But we also know that there's a very dangerous story being told around the housing crisis, in that we are, as an industry in construction, are really unable to deliver on these needs because of intrinsic problems within the industry itself. So we believe that, we put people on the moon, but we really have lacked the radical imagination that's needed to do things differently. And we believe that in order to to change the way that we live, we need to be able to change the way that we build. And this is really indicated by construction being one of the least automated industries in the world, and has stagnated really since 1947 in terms of its productivity. And when we look at some of the solutions that are out there, particularly in the construction startup space, we see that those solutions really mimic the existing supply chain. So there's a very fragmented approach to the way that a lot of these solutions are being implemented. And we see that because there's not a holistic view being taken of how we begin to address this problem. And we see also that attempts to kind of solve it all by vertically integrating have also failed us for a long time and are continuing to fail us. So the very famous example in the US is Katerra, which was a SoftBank-backed startup that achieved unicorn status in that it took over $2 billion in investment and filed for bankruptcy last year. And then in the US, for example, a very famous business, Urban Splash, had a modular spinoff called Urban Splash Homes, which fell into administration last year as well. So we see these kinds of crises happening that when you start to try to vertically integrate and bring all of these things together under one umbrella, actually they're unable to do that because they're not integrating with some of the bigger questions in construction that we think that we are able to address in our approach. Sorry. So, and we know that the building industry is really not like any other industry. We know that for example, we are the only people that are making products that are always different, right? Housing, for example, is very localized. Building is localized. But as a result of this, every building is treated as a prototype. It's much like this film where every single day we start again, right? We start again in the process of how we design and how we build. And this is a really core issue in being able to achieve the kind of planetary scale change that's needed in order to provide more equitable and just places for people to live in. So if a building is good, we've asked ourselves, why not repeat it 1,000 times? And we've seen this happen before, like for example, in London, the Victorian era, we see that townhouse typology being repeated everywhere. So why can't we think radically enough to be able to do this again? But a house is not a car, right? It's not a phone. It's not a product that needs to be the same and only have certain aspects of that object being customized, like its color or whatever. And we also have fallen into a trap of centralization, that idea of vertical integration that I mentioned. You know, we know that one of the very first proposals around this was the idea of the factory-made house from Walter Gropius in the middle of the 20th century. And we see that centralization trap essentially mimics the existing industry averages. So for example, the industry average for a house is around 225,000 pounds. And we see that the centralization trope that occurs really just increases the overheads by adding additional CapEx and only partially automates the design and engineering process as well as the labor process. And this means that other more newer approaches that try to vertically integrate like Katera, like Urban Splash, actually don't give any significant savings, both in terms of how that supply chain operates, but also in terms of costs. Essentially, that labor, that big expensive chunk, just goes into CapEx and overheads. And these examples are essentially taking the construction industry and what happens on a building site and just puts them into a massive shed, right? And this means that all of those problems from the construction site still take place, but in that big shed. So where do we start in addressing this issue? So in our approach, what we have done is we've looked at the value chain in the building industry and looked at the various stages of that value chain, from investment, development, design and engineering, manufacturing, construction, and maintenance. And we've looked at all of the other players and stakeholders that take on one of those various aspects in traditional industry. And then we've looked at some of the other modular builders like Backlog, for example, which is a collaboration between Skanska, a global construction giant, and IKEA, or Legal in General, which also has a modular housing arm. Top Hat is another big name in the UK, and Katera, which is now defunct. And we've seen that they actually try to take on too much of that value chain. So for us, we've really started as a digital builder in the design, engineering, and manufacturing space with the idea that that could have wide-ranging consequences for the rest of the value chain itself. So the building industry for us can't just be automated, because when we see that automation happening, it happens partially, it happens in a fragmented way, so it must entirely be reinvented. So for digital builders like us, we've developed a repeatable but adaptable product. And that means that repetition enables us to have the basis for any automation, and that enables optimization and improvement over time. Adaptability is important because it allows us to adapt to different site constraints, different briefs, different regulations, and we can achieve difference in terms of adaptation at no extra cost. And we're developing a product because if it's so good, it needs to be repeated. One of the backgrounds here is thinking from digital manufacturing, for example, and the idea of a discrete element, for example, that comes out of MIT's Center for Bit and Atoms, where you have the same object being robotically manufactured over and over again to achieve many different varieties of ways of building different objects. So for example, for us, we've developed, instead of thousands of parts that go into a building that mimic that, that existing supply chain, we've developed one building block that can be repeated in many different ways and allow for a great variety of adaptation or difference. This is where the discrete comes in and can be assembled together, as you can see here, in many different ways, allowing for different kinds of spatial typologies to emerge. And then also enables us to really think about how that one block can not just be developed into one house, but also can provide the kind of basis for lots of other different kinds of spaces to emerge out of it, or different kinds of interactions to happen with that building system for different uses. And this is one GIF, for example, that we developed as part of a project in May 2021. I'll show it briefly towards the end of the presentation, where we see that we can actually engage this block to developing not just all the furniture scale, but also at a much larger scale as well for housing. So in the company, we have a kind of, let's say, a 5-part kind of element to what we're doing. We have, and it's a circular process. So for example, we have a building system and a generator and digital supply chain model that feeds this process over and over again and really uses automation best to its ability, while also intersecting with known ways of working within the supply chain in terms of delivery. For example, in the way that buildings are assembled on site or in a factory kind of setup. And what this has enabled for us to develop is a very local, low capital expense and low entry form of automation, where essentially you see our entire production line needing very few amounts of automation or different kinds of automation to be able to deliver any number of different kinds of homes. And this means that we can appeal to the building industry in a way that makes automation much more accessible to them, and thereby being able to work with many different stakeholders in that process rather than just one or two. So for example, what we have developed as an approach is that we essentially are powering an entire ecosystem of builders, particularly SME contractors, which make up in the UK and Europe 99% of all house builders. This means there's over 3 million SME construction enterprises with under 250 people, and the vast majority of those businesses are 1 to 2 people. They create 80% of all construction output, and in the EU, they comprise 9% of overall GDP, so this is a huge number of people that are very important, and businesses that are very important in this industry that currently do not have access to automation, but they can gain access by working with our approach. This has also allowed us to go from robotic building, in terms of robotic building, to do robotic assembly. So for example, we are able to use a very off-the-shelf industrial robotic arm, develop a modular and scalable and low-cost form of integration with that robotic arm that allows us to assemble our building blocks very quickly and then assemble them together to comprise different kinds of structures that then turn into homes. Our building system can be assembled in 45 seconds using our robotic platform. This is an image of that one of those building blocks, well, a couple of those building blocks combined together. This is a 2.7 meter tall unit that essentially is an entire spatial, it enables us to create an entire space. And this is a kind of integration that we're able to achieve. So for example, we are able to have a block, the block acts as a base unit for all aspects of, let's say, an entire volume. So it is integrated with the facade, but it also integrates the door, the window. It acts as the base for everything. It can make compartments, panels, and volumes, as well as all the kind of integration with MEP and things like that that we need. It also has provided us an opportunity to work with communities. So this is a really important part of onboarding, in onboarding stakeholders. So we've done a lot of work in the UK with really working very closely with communities to explore how automation can enable them to design and build their own homes and spaces. This project was Block West, which we did in 2020. there was an age group of 17 to 80 that were involved in the project, and it was 50% women and 50% men, which is very obviously very something that doesn't happen a lot within the construction industry, and is now really taking flight in the UK here, with community-led housing groups that are using our tools and using our approach to be able to deliver houses locally. We also did this in May 2021 with Hackney Council, which is a local government in East London, a very large local government in East London, where we worked with local residents and community members, as well as policymakers and cultural institutions in that neighborhood, to design, build, deliver, and publicly program this project House Block, which acted as a kind of scaffolding for activity to engage the community. So the project itself wasn't just an object that we built and then we said, hey, look, this amazing thing, what do you think about it? We engaged people in a paid program of training and work experience to be able to use the construction, the design, construction, disassembly, and its activation as a public space, as a kind of platform for these discussions to happen, as well as skills building and other forms of learning. In just before COVID, we also built our very first office and residency space, which was an open space in the building center in central London. It acted as a co-working hub for over 6 weeks. And we were able to really explore the potential of how this kind of open-ended space could be used and also activated by the public. Since then, we've built a number of different ADUs where we've been able to train ourselves, train our teams, train our robots, and really begin to understand how we could begin to take away some of the pain of the contractors that ultimately we want to be working with our technologies. These were very fast-paced projects, and we learned a lot during this time. We're now starting to move away from this, but they're there, they're being lived in, they're being used on a daily basis, which we're really excited about. We were also selected as a result of some of this work as one of 12 green tech innovators by the UK government in October 2021. You can see here one of our former prime ministers being just absolutely astounded by the fact that a robot could lift something. But this was a really interesting moment for us because we were alongside companies like Arrival Cars, which also have a very similar approach to us in terms of manufacturing electric vehicles, and then alongside Rolls-Royce as well, which is a really interesting company when it comes to logistics automation and supply chain automation. So this moment for us was really big. It gave us this huge opportunity and platform to begin to be able to demonstrate what was really possible when you begin to embed robotics in the production chain of how we design and deliver homes. And really, these are mass customized products. So, you know, the mass customization trend of the early 90s and early 2000s for us really set a stage, set a kind of problem to the industry and to architecture, where it said that in order to get mass customization, you have to post-rationalize after the design phase in order for things to get built. And that really created a massive gap and increased the time and budgets of these projects. So for us, we're looking at how can you get a standardized product that allows customization, and we've built or are building all of these small projects either last year or this year. And they're all exactly the same in a way, but they're all very different in terms of their use, their spatial arrangement and typology, and also their kind of atmospheric qualities. We're now shifting again towards this notion of productization. We know that we have to make spaces that are incredible for people to live in. So we've developed a default house type that we launched actually yesterday at the Industrialized Construction Forum at Stanford, which is a house that can be adjusted to various different building regulation environments or contexts or sites, and but without changing the manufacturing of the design or manufacturing process that we use. So that means we can adapt to very many different kinds of places without actually having to, add additional cost or time. And it's beautiful, right? We can all agree. At least I probably want to live in one of these. So right now we're working across 2 to 3 stories, delivering houses in the UK and EU. And this is really a series of pilot projects that unlocks from 2024 onwards up to 6 stories of housing, which is really the sweet spot when you want to think about densifying cities or densifying neighborhoods over the next 30 years to deal with issues around climate change in particular. So for example, this is one kind of image that we created of what a community based on our building system might potentially look like when you have different kind of densities and different kind of house types developed there. So instead of developing a design platform that is, let's say, configuring like known designs, instead we're working with the idea of the generator. So this generator can take any kind of plan and generates what we call a block model from it. And then that block model gives us various different options in terms of what it might need in terms of customization, and that customization is automatically generated. It also automatically gives us all of the information that we need about a singular project. And that means that we can give very clear and very automated and accurate costings and timelines for the projects that we're delivering. So this is kind of the dream scenario, which we're working on right now, where essentially you can take any sketch and you can generate various degrees of options automatically with our software platform. And this is how, if you zoom in a little bit, this is kind of how, on the right-hand side, how you might see this this working overall. This is kind of a diagram of everything that we do. And we've developed a series of automations that interface with really high value adds for us in terms of how we might improve on our productivity and improve on our delivery and timelines. So for example, these automations are very easy to be able to quantify, because we have only one building block that we need to know everything about. So because we only have one building block, we're able to know all of the materials attached to that. We only have about 20 materials that we use to do one house. And we're able to control all of the robotic integration with it as well, which is a really interesting moment, we think, in simplifying and making an ultra short design and production chain. We're also working on automations, very practical automations as part of this, in terms of the form of apps. So this is one that we use with our more casual labor that we hire onto our projects in terms of delivery, where we have developed a tool that allows them to very quickly see all of the risks with a task that they need to do. It allows them to have access to all of the diagrams or images or plans that they need in order to do the assembly on site. And it also allows us to be able to track how they are finding the tasks that they're doing, and also provide us with feedback so that we can improve on our processes iteratively and not lose any of the knowledge that's created in one project once that project is finished. So this all comes together in what we're calling a Microfactory platform, which is a very low capital expense platform. Our closest competitor is Kubi Technologies. Their Microfactory platform costs in between £5 to £7 million. Ours cost in between £300,000 and £700,000, which is a significant cost reduction in terms of being able to have that low threshold access to automation. And it's modular. So essentially, if you have an area where you need to develop homes that the numbers are bigger, you can just copy and paste and modularize the factory so that it can have a greater capacity. And because it is also modular, if, for example, you set up an area where you have 200 or 300 homes and that project's finished, we can very easily take down that factory, absorb it back into our network, and be able to reset up in another location and expand the setup somewhere else where it's most needed. It also allows us to do what we call parallelisation. So in a typical factory setup, you have the assembly line, the Ford model of the assembly line, where you have very codependent processes. So you can't move on to the next stage until you finish the first stage. And this creates a really difficult thing if, for example, one part of that chain doesn't get complete, right? It can really impact on the overall performance of the factory itself. So instead we have several different processes that can take place in parallel. So one robot can be assembling blocks, one can be assembling a bathroom pod unit, one can be assembling walls, one can be assembling the full volume. And that no part of that is dependent on the previous part having taken, or another part of that being taken place. So we design our projects with that in mind, and we can automate our supply chain really easily because of this. As you can see here, you can have these kind of 3 different stages. This is just a bathroom pod being finished. This is our microfactory space that we're setting up currently in East London. We had been working for the last 18 months at ABB's ABB Robotics UK headquarters, where we were the only startup that had a robot cell in their innovation center. And we're now moving and transferring that setup to our space in East London, where we'll be delivering a whole huge pipeline of projects in 2023, 2024. And this setup really, it outperforms the more large centralized setups that I showed previously, like a Terra or Legal in General or Backlog. So instead of one large modular factory requiring 60 million pounds just to set up and 24 million in OpEx, for the same capacity, we cost 1/5 less and 1/3 less in terms of CapEx and OpEx for the same capacity, which is a really exciting, I think, moment for the industry. It also has this kind of impact. You'll remember from earlier on my diagrams around the industry average and modular average. So with us, we're able to reduce the amount of labor into CapEx and automation, and then increase the amount of margin that our contracting partners and delivery partners get, while also reducing costs significantly. So that means that we can all of a sudden enable people who wouldn't be able to access affordable housing. We can access it while also increasing the revenue streams of those partners and increasing the margins of the sector at whole. So for example, a typical build cost for us is around 225K. And we're able to, we can adjust that margin as we see fit, but we're able to cut it by almost 1/5. This also has a big impact in terms of build time. So the industry average for a house is about 36 weeks. We're able to go from design to site install within 6 weeks. In terms of energy costs per year, this is also a huge significant, because of our building system already meeting passive house accreditations, we're able to have a significant savings in terms of heating costs, which is obviously a really big topic right now in the UK, where we have an energy crisis and costs are extremely high. And it also has a big impact in terms of carbon emissions. So each individual house, instead of creating 100 tons of CO2, has -12 tons of CO2 per house. So our first microfactory, our first external microfactory, so we have our own in East London. We're also setting up one in parallel in Belgium, where we have a large pipeline with a large contracting partner that has around a 250 million pound turnover called Van de Busse. They do a lot of different things, but they also do their own development in terms of housing. And from that, we are onboarding 2 additional smaller contractors, such as Declare and Kaiser, who are working with us as well and onboarding themselves as manufacturing and contracting partners, working with our building system and technology. This year, we have a really huge amount of projects that we're doing. So we're doing 10 small ADUs. We're doing 1 large test case villa. We're doing 16 small single family homes, 5 single family homes, and then 12 units, which are called uptopping in Belgium, which are essentially 12 units that go on top of an existing building that's being refurbished and retrofitted. So our building system, because it is in a way agnostic to the way in which it's delivered. It can be delivered block by block, it can be delivered as panels, or it can be delivered as full volumes. This means that we can work across many different sites and many different site constraints than any other building system that's out there. And that has wide-ranging consequences for us to be able to work in many different regions at the same time. It allows that scalability that we need in order to be able to deliver on the kinds of homes that we need globally. And it's also allowed us to explore the potential of if we could develop a typology for projects that first is a microfactory and then turns into housing. So this is a project that we're doing next year with Revive, which is one of the top 10 sustainable developers in Europe. They develop primarily on brownfield sites, where essentially we have the microfactory setup that then delivers the homes from that setup itself. So this is just an example of how it then gets, the factory then gets just slightly retrofitted using the building system to turn into homes after that project is completed. Just a couple of images from that project. And we're also always testing this. So for example, we built a small section of that microfactory earlier this year. This was also a community-led project in central London, sponsored by the Mayor of London, at a cultural organization and arts institute called Somerset House. And we tested out how we would be able to build that section. And we use opportunities like this really to further the kind of practical R&D that's needed to do those large-scale projects further down the line. So that's just an example of what that might look like. This was our first moment going from a smaller scale block to a much larger scale block suitable for going higher than 2 stories. And our roadmap right now is that in 2021 and 2022, we developed those ADUs really as MVPs. This year, we're opening Microfactory 1 and 2. And then through those processes, we're kind of proving and validating our approach in the US, in the UK, and in Benelux area of Europe, so that from 2024 onwards, we can really replicate it worldwide, which is a really exciting, we're at a very exciting stage right now for watching how this takes place. So yeah, we're working towards a network of 1,000 microfactories by 2030. That's just over 3,000 robots, and the capacity that that gives us is 50,000 homes a year. And that's just a drop in the ocean for the amount of homes that are needed and for how we might, we don't know, right? We know that we need billions of homes. So we're hoping that by doing this work, we're having a large impact in the way that this industry might approach this problem, but we recognize that it's still just a small amount that's actually needed. But what we'll be able to save in terms of embodied emission per year is 4.8 million tons of CO2 per year if we were able to achieve this goal. So yeah, say hi if you'd like to learn more about AUAR. My email's here and Jill's email here, and I'm really happy to spend some time taking questions. Thanks so much.
Okay. Hi, can you hear me?
Yes, I can hear you.
All right, my name is Matthew Petrus. I'm a second-year Bachelor of Architecture student, and I was interested about the adaptability and customization of your modular structures. A lot of the adaptability seems to be before the buildings are actually manufactured. Is there any customization or adaptability that remains after they're built? So like, could you go in a building that's built after and then change the configuration if needed or something like that?
Yeah, so there's a couple of ways that we do this. So we've done this already with our project in our project Block West. So that has actually been adapted several times over the last 2 years for different needs that community have. So what we've done is essentially we've modularized not just the blocks themselves, but also the the cladding, and all of the other finishes that we have. And what that means is that we are very easily able to disassemble and reassemble the building blocks into different arrangements. And that's based on the principle of digital materials, which is the idea of reconfiguring over time, right? So the answer is yes. When it comes to a house, we have modularized the vast majority of this. What we've seen is that we are essentially leaving, we've essentially developed a shell that has a lot of room to grow. Yeah, so you can do things like essentially do a retrofit to it, very simply by adding on more blocks, and you can change the internal walls as well without a huge amount of change. For example, I live in a terraced house in the UK. It's made of stone. Very difficult for me to adapt my home. In our system, you can actually adapt the internal walls much more easily.
So I was kind of curious about the materiality, because obviously that plays a huge role in sustainability and scalability. So like, what materials are you currently using? What other options have you explored, and how easy would it be to adapt the modules to a different material?
Yeah, totally. So that's a great question. So we have always worked in timber because obviously it's a great material in terms of its strength, weight, cost ratio. We use a CLT, and our blocks are a CLT and glue lam composite, a CLT sheet. We work particularly with one type of CLT sheet that's made by a sustainable, a manufacturer that works in sustainable forestry. They actually own their own forests in Austria. And the glue lam is beams that we use to make the structural sides of the blocks are very easily accessible glue lam. The goal really is to work with very off-the-shelf materials, because that's how we achieve scalability across different markets and across different regions. So if we're using really off-the-shelf materials, that allows us to input ourselves into any supply chain that already exists without having to source custom materials, right? So that off-the-shelf thing is really important. And then in terms of other materials, we essentially can use any sheet material that has the right strength, weight, and cost ratio. So we've explored a couple of them so far in terms of, there's some interesting recycled plastic sheet materials coming out now, but what we found is that none of them are available at the industrial scale that we need in order to build the houses that we need at this point in time. But in the future, we're pretty open to exploring different ones. In terms of cladding, this is where we're pretty agnostic right now. Actually, in our projects that we've built ourselves, we've used the same CLT sheet that makes the structure as the cladding, but we're agnostic to that. So for example, we're exploring right now with one of the largest brick manufacturers in Europe, modularizing their brick product to work with our building system so that we can work with ceramics, for example. We're also exploring hemp and other bio-based materials as well.
Thank you.
Yeah.
So I have a question for you. I personally study the work of Gropius and Voxman extensively, and the package house system. I see a lot of similarities in the way that you're approaching problems. I'm sure they would have loved to have had the automation technology we have today. And one of the things I think that what is always like a lingering aspect of that is being a fascinating system for me is how it ultimately failed. And the part of the reason being that, at the time it's suspected that the American people weren't ready to embrace it. And I just wonder how your experience has been with the climate of the society accepting this as sort of a new method of building has been.
So I guess there's a couple of different ways to talk about this. So one is around the perception of end users.
Mm-hmm.
So I think that's kind of what you're getting at. Now, when it comes to end users, people who are living in these homes, what we found is that if the price is right, people will buy it. And what we want to make sure is that we are not designing and building really low quality homes, right? So we think that there's a really interesting intersection for the perception of the public around cost and quality. And we've developed a system that essentially brings high quality, but low cost or affordable cost, like truly affordable, right? In comparison to any other thing out there. We also give a cost guarantee to all of our projects. So when we freeze the design, that cost is guaranteed. That's something that no one else provides out there. There's a couple of different, like flat packers or whatever, but then you incur costs much further down the line, right? And we're mitigating a lot of that. And then the other side of this conversation is really around contractors. And I just saw a question come in about this from the chat, but this is a really interesting question. It's, have you had a strong pushback from traditional contractors? Actually, we've done a lot of market research over the last couple of years where me and Jill have gone out and had conversations with contractors about their needs. We know that there's a huge number of contractors who are essentially going defunct, not because they don't have the work or the pipeline, but because they don't have the people to take over their businesses. So what we have done to them is recognize that that need is real, and they're not having their sons or their daughters come in to take over the business because nobody wants to be in construction anymore. So that labor shortage is a massive problem. And essentially we're saying, you can become not just a traditional builder, you can become a builder that has digital tools available to them and you know how to use them. You can actually expand your business and you can make your company much more appealing to a younger generation who traditionally wouldn't have gone into construction if they were doing the dirty and dangerous, right? We can actually make jobs that are way more appealing to that generation by working with us. And so traditional contractors have actually been amazing with us when they see that we recognize those needs and we recognize their pain points in their business, they sign up. So currently we have 5 contractors sign up. They have over £1 billion in turnover amongst them already. And we have a wait list of 50 contractors, and that's just with UK and Belgium, right? And those are small markets in comparison to other places in the world. And that's without actually going public yet, right? So once we go public, that we're actually seeking that out, it'll be a different case.
Mollie, we've got a room full of architecture students here. Even though I saw on the AUAR chart that you were in the realm of digital and manufacturing in terms of your approach, I think you covered so many other fields and disciplines today, from the economist to the real estate developer to the cultural anthropologist. Can you talk about how you've had to expand beyond what you used to be as an architect, and maybe talk about some of those growing pains?
Yeah, sure. So, I mean, I think I have a relatively unique background in that I trained as an architect. I specialized in architectural theory, and I've always worked in design computation environments. So I'm of the 2008 generation, right? Like I finished Pratt in 2008 and we all couldn't get work. So we had to really think creatively around what are the problems for our industry? Like what kinds of practices do we want to have? And I think there's a whole bunch of us, some of which will be named, the students will know who they are, that have come together and collectively worked on, I would say, a political project within architecture that sometimes gets called the discrete, sometimes gets called discrete automation, that really is trying to vastly rethink what our role should be as architects. So we believe that, I'm speaking for the group, I shouldn't do that. But I would say, generally speaking, there's a consensus around the fact that the master genius architect model has failed, and it's failed time and time again. It's not just failed in the 1950s. It's not just failed in the 1960s. It's failed in the 1990s and 2000s. And if it's going to continue to fail, then obviously we need to rethink it entirely. So I've always thought of myself as an enabler, and AUAR as an enabler, more than AUAR as having the answer to, all the needs of the, trying to come up with this genius idea of this individual building that's going to solve all the problems. So that's why we have made ourselves be really uncomfortable and going out into industry and having those conversations with contractors and with developers who have very different values to us, right? So a developer is all around money and profit margin. A contractor is too, but they have no wiggle room because they have to bow down to the developer usually in terms of those margins. The architect is single-handedly not able to be affordable to the vast majority of the population. Also has to go through a bidding and competition process that undermines, let's say, our expertise and knowledge at every point. And so we've tried to really rethink what that could look like, right? So like part of our customers is, our clients are architects. They're architects who see that by working with us, they can take away the pain that goes into not knowing if something's going to work, and actually being able to have creative freedom, be able to take on more projects and be able to serve a much wider and lower their prices and take a much wider range of work than they ever were able to take before. So in terms of, we have contractors and we have developers, but we also are leveraging, I would say, our profile as architects and designers to really appeal to a huge number of people in the industry who are have been sidelined by this master genius model. I hope that answers what you asked.
Thank you. Yes, go ahead.
I just had a quick question about how you guys fastened the modular pieces together. Like, did you guys use different pieces depending on where it was located in the house or anything like that?
No, the connectors are the same everywhere. So it's a post-tension system. It used to be a kind of classic post-tension system with steel rods, and it was really tedious and annoying to do, and it was very difficult to automate. But we've moved to a key lock post-tension system, so it's the same small component everywhere, and yeah, it has a huge advantage in terms of strength. So, for example, one of the connections on the short side of the blocks can take over 600 kilos of weight, and a long end to long end connection can take over 1,000 kilos in weight, which is it's a lot of weight. And we can also get massive cantilevers. We've done an 8 meter, 12 meter long, I think 12 meter long cantilever before without any additional post tensioning. So that in itself is it's pretty fun to be able to have that freedom.
So a lot of the work that you've been doing so far has been in the England, Netherlands area, and that has a particular climate that's associated with that. If you have future plans to spread this type of building construction, do you have any plans to adapt the overall design to other climatic extremes, especially in the advent of climate change?
Yeah, so we are working already in terms of North America. So we already have projects there. We already meet residential standards across North America and Europe. In terms of South America, there's quite a lot of opportunity there in terms of places that have more temperate climates. We're getting a lot of attention from the Middle East, but we will have to shift material system to be able to work there. And there is some argument about reforestation that's happening on government levels in certain countries in the Middle East that might mean it's possible to work in timber, but again, like I don't know if that's actually possible. And we're getting a lot of attention in terms of India as well, but again, we will have to switch material system for that to be able to be possible. And then in terms of Southeast Asia, we think that in countries that already have timber as the backbone or more traditional ways of building, we're looking at those as potential places to be working.
Last chance for a question. Anyone? Okay, Mollie, thank you so much. Fantastic work. Really great.
Thanks so much for having me.